Thank you, Don. Well, welcome to the BricsCAD BIM workflow session. We know that we're the only thing standing between you and lunch, so we're going to try and make this as entertaining as we can. And we do accept oohs and ahs. Thank you. BricsCAD Ultimate, the workflows that it helps, we're here to show you some of the workflows that it can enable to unlock your design creativity. My name is Kevin Settlemeyer. I've been on a BIM journey for a few years, as you might be able to tell. My journey started quite a number of years ago with a small startup company called Revit. It's been an interesting journey, and it's one that's had a more interesting chapter as I've been able to collaborate with the BricsCAD BIM team for the past few years. Each year we try and find a interesting and new project type or new way to tell the story of the current or the new BricsCAD BIM version. Last year we showed you the Twisted Tower, and this year the inspiration comes from railway station designs. So the demonstration that we'll be showing you is called the Flowing Station.
Hello, my name is Timon Strobbe, and I will be giving the presentation together with Kevin today. And I'm joined here on stage as well with two more colleagues, Peter and Jacob, who are brave enough to do the entire demo live today. So they will create the rail station project in a collaborative workflow. So they will be using BricsCAD 24/7, which is our cloud-based solution. And they will guide us through different stages of the rail station project, and each time, step by step, create different parts of the model and upload it to the 24/7 cloud in order to sync it and to make it available for the design team members. So the goal of today is to show you the BricsCAD Ultimate workflow. So what exactly do we mean with BricsCAD Ultimate? We will start with conceptual design. We will show our intuitive direct modeling tools to create a conceptual design from scratch. We will then add the data to our model, so the information, the BIM information, using our artificial intelligence tools. And we can then go to design documentation. So we will show you how you can easily generate your 2D drawings from your BIM as well. Finally, we will increase the level of detail of our model to make it suitable for manufacturing and fabrication as well. All of this we will show on one platform, BricsCAD Ultimate. So let's get started with the demos.
So the Flowing Station is on a major rail line just outside of the city. It has 3 main buildings associated with it. On the east side, which can be approached from the bike path, will be an area for bike storage and also the new headquarters of the Travel by Bike organization. Currently, it's just a footprint. On the west side, this will be, which can be accessed by car or by foot, and it will be the railway station operations offices, as well as a major entry to the terminal. These 2 buildings bracket the terminal, which is spanning across the tracks, connecting the 2 buildings, and also providing access to the platforms below. This is the context for the current design. But as you can see, we've got quite a bit of work to do, especially since it's not living up to the term flowing just yet. We can start with the east building. From a footprint that is part of the grid, we can just create an initial solid. We can highlight a surface, select rotate from the quad, and quickly change the angle of it. We can start to do this on a number of different surfaces to begin to sculpt the form. What we're wanting to remind you of is how easy it is to model with BricsCAD BIM. You've got tools like extrude, push-pull, rotate, and others right at your fingertips. So you can focus on the important things, the design. And, oh, by the way, if you notice that Jacob is using the dark UI as well. You can also start to create polylines in a way that you can use to create different boundaries, different ways that you can then select those, extrude those to create voids. And then we can start to quickly manipulate the form in other ways, so that we can begin to start to create a companion form to the west building. But the important thing is that the design doesn't have to stop here with just manipulating the form. What we can begin to do now is start to transform this into a more refined design. So we can select the overall solid, and we can now use shell to transform that into an envelope that's going from the outwards in. Now this envelope is obviously a continuous envelope, so we need to do a little work in terms of how we're going to separate that envelope into linear solids. These are tools that you may be familiar with, but we can use tools such as slice that allow us to look at that intersection of where things are coming together, select a surface, and separate those, so that then we can start to get the set of linear solids that we want. We can also use tools such as BIM split, which allow us to do that for multiple ones as well, for multiple intersections, so that we can get to the desired set that we want fairly quickly. And so at this point, then, we can start to step inside and work with some other, where we can clean up some of the forms that may not have transitioned the way we wanted it to. Quickly do that. We can also separate and put a partition separating the vertical bike storage from the travel by bike organization headquarters. And now we're at a phase where we can use BIM drag to create multiple levels, where we can use the distance scaled as it appears, or we can input a value directly into the dynamic dimensions. We can easily make adjustments to that, select edges, and reach to nearest so that we can get to the sloping wall surface as well. Now, we're not going to win any awards for interior design here just yet. So what we can do is also use BIM drag to create other partitions that are primary partitions that are going to be part of the building. So fairly quickly, we've now got some of the interior laid out, the floors laid out, and the envelope, but it's pretty boring at this stage. So we can start to introduce some transparency to this. We can select surfaces, we can offset those to create other boundaries. We can use BIM window create to generate a parametric window. We can start to step to the long side of the building and maybe break that up by introducing a line that starts to break down that overall surface into multiple boundaries. Again, we can use things like offset if we wanted to keep the glazing a certain distance from the edge. And again, we're just trying to get initial ideas down. So we can copy lines to create or refine or break down that boundary even further. So ultimately, then we're getting to the set of boundaries that we want. And again, we can use BIM window create to do it. Now, the important thing to note is that we're not just creating transparent representations here. These are parametric windows that we can adjust and refine as we move the design forward as well. Part of the goal is that we're trying to also have this be a companion to the west building. And a key characteristic of that is that it's making the larger form appear that it's resting on a glass box. So ultimately, we want to start to create the set of surfaces that we can do to get that design idea in place. And this is something, this quick modeling is something that BricsCAD takes very seriously in terms of how you can start to work with these, work with surfaces and other things to create these kind of components. So what Jacob's doing now is he's using the curtain wall tool to ultimately set an initial module for the curtain wall assembly and then create it. And we can quickly do it on the other side as well to get the design idea in place. So entering the dynamic dimensions, creating the module, and then we're able to create that set of curtain wall panels. So now we're at a point where we want to start sharing the design ideas with the project team. And we used to have to do that by going to 24/7 and then uploading the file. But now, as you heard earlier, with the 24/7 panel, we can stay within the BricsCAD environment and start to do that. So this contains all the project drawings. The east drawing, you'll see a little icon that says locally modified. So that means that we've made the last changes and we need to update it. So we can select upload. And then we can add a description to this upload or to this version so that we can tell the team what's what some of the changes are, and that's just initial design ideas. Then we can upload it, and you get status, but then you also get that it's up to date. And so now, Jacob, since he's also still in BricsCAD BIM, he can start working on the rest of the exterior elevations or design ideas for this. So Tiemann, why don't you show us how we can create a canopy that starts to give some movement to the design.
So here we can see an architectural concept sketch which shows the initial idea of the flowing canopy. We want to create some kind of grid shell that is flowing over the terminals and the tracks. And this grid shell needs to fulfill several requirements, like it has to be structurally sound, of course. It should offer rain protection, wind protection, and it can also serve as a system for sun shading and for providing natural lighting below the canopy. So we are in a very early design phase, and we want to capture this design intent, this design brief, in the form of a parametric model. The way we can do this is by defining the parameters and the relationships that will build up such a parametric model from bottom up. This kind of approach, we call it algorithmic modeling, has the benefit that you can control the geometry of complex structures like this canopy in a very efficient way. And you can also very easily explore design variations. So by changing some of the parameters, you can see how this will influence the design of the canopy. So algorithmic tools are available in the market, but they are typically used in a very early design phase, long before BIM tools are even involved. And in order to bridge this gap, we have partnered with McNeil to implement a connector tool between Grasshopper and BricsCAD BIM. So this connector tool is based on the Rhino Insight technology that was developed by the team from McNeil. And they will also give a presentation tomorrow. So if you want to hear all the details about this technology, please make sure to follow their presentation tomorrow as well. The benefits of this connector tool is that we can now support a real-time bidirectional workflow between Grasshopper and BricsCAD BIM. And we also offer a toolset of BIM-ready components that can be used in the Grasshopper environment. So let's now show you how this works in V20. So the connection between Grasshopper and BricsCAD BIM will be available as an application free of charge from the App Store. It will be part of the Bricsys collective. So the goal is there to provide a very smooth user experience for our users to get, to download, and to install these kind of applications. So with this application, it will be possible to connect to Rhino and Grasshopper. If we have the application, we can launch Grasshopper from the quad, and we can now see the Grasshopper application running on top of BricsCAD BIM. We see here the network, the Grasshopper network. It looks quite complicated. It defines all the parameters and the components, and the wires that you see are the different relationships between these components. So this network completely defines our canopy. We have created this beforehand. But we could also see that some input parameters were still missing. So we have to select two input curves, and we can select curves inside the BricsCAD BIM model to connect the Grasshopper script to BricsCAD BIM. If we do that, we can see a live preview of the geometry that was created in Grasshopper immediately in the BricsCAD BIM environment. So in other words, this means that Grasshopper is now running inside of BricsCAD BIM. This is a real-time dynamic workflow, so we can still make changes. Like Peter just adjusted the input curve, the line. You can see that it immediately changes in the model as well. We can also change parameters, like the amount of shells, for example, 9 or 12. And like this, we can explore different design variations. So you can see that everything is running very smoothly, and you can real-time see the effect of the changes in the model. We would also like to take this integration one step further beyond geometry, And we have added a tool set inside Grasshopper that allows you to add, for example, classification types to your Grasshopper geometry. So you can add any BIM type, which is closely related to the IFC schema. You can associate this BIM data with your geometry as well. So you can choose from a list of all the possible IFC types. Like in this case, we are going to use column, roof, and window to classify our entities. And as a result of the principle, design first, then add your data, this is very easy to accomplish with BricsCAD BIM. So you have a lot of freedom to create geometry and add your classification data to it later. If we are happy with the result, we can bake this geometry, that's how they call it, bake the geometry to BricsCAD. And baking means basically that you translate the preview geometry that we just saw to actual native BricsCAD BIM entities, so actual 3D solids. If you bake the geometry, these entities can be used for further editing in BricsCAD BIM. So for example, you can use it to generate 2D drawings, to extract schedules, or to export to IFC. And if you do that, also all the additional data will be available. So for example, the classification data that we have added, if we select one of the columns, we can see that this data is available. Also layers, materials, properties, structural steel profiles, all these kind of components are available and can be used in combination with Grasshopper and BricsCAD BIM. So if we are happy with this result of the canopy, we can reload the XREF of the canopy in the overall model to see how it looks like in the context of the overall rail station. So we are happy with this first conceptual design, and we can share this model again with the team by uploading it to 24/7. So we can add a short description. And now the canopy will be available for everybody who's involved in this 24/7 project. Meanwhile, while we are looking at the the 24/7 panel, we can see that a newer version of the East building is available. This is the East building that Jacob has just been working on. So he has created the initial conceptual design. So Peter can now download it to his local machine, and he can see the version that Jacob has just created in the context of the overall rail station model. We can also see that this East building is not quite ready yet, so a lot of detail still needs to be added, like windows and compositions. So we'll now switch back to Jacob's screen to see how he has progressed.
A few oohs and ahs, maybe? Thank you, team, and that's a fairly hard act to follow, although, if you'd noticed, Peter's using the light UI, but we'll let it slide. Kind of going back to the East building and looking at what the stage of the design is, Jacob has continued to work on the facade ideas for this and started to develop the initial glazing, started to do a little more work on the interior, and also create some of the core elements such as the elevator core. We can isolate a portion of this building and start to develop another core element, the stairs. So there's a new BIM stair tool, and what it allows you to do is quickly select a starting point, and we can create a stair that wraps this elevator core and has multiple runs. So we can do that by selecting an initial starting point and then setting the directionality of the stair and then selecting the endpoint at the top. Once we do this, it creates an opening at that landing floor. That's a parameter of the stair, so that can be changed. It could be set to code requirements or regulations, or you can use tools such as BIM drag to just recreate or put it where you want. So when you're creating the stairs, there are alignment aids with it and a stickiness that helps you select the starting point. And then as you start to move up with it, then the directionality of the stair starts to take shape. You're able to visualize it. You're able to look at the length, width, the size of the stair, rather than a let's wait and see approach. So once you start to get used to BIM stair, you'll find that it's easier to use to just create the stair than it is to copy it upwards if you were doing it for multiple floors. So BIM stair is an an intuitive way to create the stairs for single run stairs, L-shaped, U-shaped, or any other letter-shaped stair that you want. So now let's go to the interior quickly. So one of the design team members has laid out a 2D layout that we've incorporated already into the model, so we can display this. We could use the polysolid tool to begin to create the 3D walls for this, or 3D solids, but we'd have to set the heights, we'd have to change the thicknesses multiple times, we'd have a lot of stops and starts. Wouldn't it be nice if there was a tool that adapted to what that layout was? As you might imagine, QuickDraw has some new features that enable us to start doing this. It adapts, as you can see, it adapts to the width of those walls, whether it's a single wall or a second wall that's at 90 degrees to it. And what we're able to do is start to quickly do the layout, create the layout, and it turns into more of a 3D BIM game than a tedious exercise. So when you're creating this, it also is aware of other solids that are present and the exterior walls and other things, so you don't have to be as precise. You're able to lay this out fairly quickly. And as you notice, there's also these alignment aids that help in selecting the point where you want it to be. To tie back to the BIM stair side, if you had a design that had multiple floors of the same interior layouts and stairs, QuickDraw can also copy those interior walls and the stairs upwards as well. And you can use all the other tools within BricsCAD BIM with it. So you can use BIM drag to create other partitions within it. You get to decide how quickly you want to create and the ways that you want to do things. But the important thing is that you can do it QuickDrawly. QuickDraw plus LY. We'll move on. All right, so now we have a number of linear solids associated with the model, with our BIM, but they don't really have a lot of data, so it's a good time to start to introduce data into the BIM. We can do that very quickly by selecting BIMify. And so what this is doing, as was mentioned before, it's creating the representation of the building, it's setting the levels, the exterior solids are becoming walls, the interior solids are becoming walls, it's setting the floors, and we're also getting the elevations and the floor plans associated with that. So it's adding a lot of data pretty quickly to the BIM, even more quickly than I can, or even quicker than I can describe. But the idea is, isn't that the way data should be? It should be able to be added to the model as we progress, and we don't have to input it. So now, once we've done that, we can look at how it's categorized. So the structure browser ends up displaying the categories for those different classifications. So by selecting those, they're highlighted in the BIM. So you can quickly see which things are under what category, the quantities, and also some have additional refinements or additional filters. In the case of walls, it's also scanning and looking at what are exterior walls and what are interior walls. So it's automatically setting that up for us. But now we're at a point where we want to add another level of detail to it. And there's a tool called AutoMatch that we're going to talk about now. BIMify, what we just showed, classifies things. But if we wanted to add compositions to the overall model, we can start to do that as well. So with the compositions panel, we can identify the composition that we want, and we can drag it and drop it onto an exterior wall. You get a visual indicator that it occurred because the wall is displaying a material. Now we can step inside and we can do this also for an interior wall and for a floor. What we're doing is we're introducing the unique compositions to this model. Once we have those in place, then we can launch AutoMatch. But we have a few options here. One that we could do, if we wanted to just select the compositions in the west building, they could be applied to this building. But since we've started to already apply compositions, we can use the ones that we have and use autocomplete. And this is scanning the model for the solids that are the walls and the slabs and the walls, the floors, the interior walls and others, and it's looking to see if it can apply those compositions to that. So, might just be me, but it seemed like fairly quickly we're getting the compositions assigned to the exterior, and we're getting that additional level of detail. So all these walls now have all the composition associated with them. And if you notice on the structure browser, it's now being categorized by the composition itself. So we have different ways that we can begin to slice and dice the data further. So you can imagine the time savings as models increase and the complexity increases of what this can provide in ways of associating data into the BIM. Now we can also start to share this updated version of the East building with the design team. So again, we can go to the 24/7 panel. We can upload our locally modified version. We can include a description. And then it's there, and we're able to move on. So, Teeman, why don't you show us ways that we could start to auto-create drawings for this East building?
So, Jacob has finished the modeling and adding the data in the East building. So we will now see how Peter can create design documentation for this project. So when we talk with customers, we often hear that they spend a lot of their time on generating the 2D deliverables. So generating the drawings, annotations, dimensions, it's a time-intensive job. While rather they would spend more time on the actual design or on the 3D modeling of the BIM. In order to allow this, we will now show you several new ways how automatically generation of 2D drawings can be automated. In the meantime, we can see that Peter has downloaded the most recent version of the East building that Jacob just created. So we can see that the render materials are applied. We can see the staircases. We can see all the level of detail that Jacob has introduced. So we are working on the most recent version. From this, we will start creating the drawings. On the left of the screen, you can see the project browser. The project browser is the control center to control and manage all your 2D drawings. So including floor plans, elevations, sections, but also schedules. So Peter is now using the project browser to show you a quick tour of some of the sheets that were generated beforehand. And while he's doing that, I'd like to explain a new functionality in V20, which is background updating. Background updating means that multi-core processors will be used to update all the 2D drawings in a background process. So this means that you can just continue working on other parts of the design while all the 2D drawings are being generated, and you no longer have to wait until they are finished. So here we can see a floor plan that was generated with BricsCAD BIM. So it was automatically generated, tags were added in an automatic way, and with very little effort also dimensions and annotations were added. So this is the kind of level of detail that you can easily accomplish with BricsCAD BIM. We will now show you how you can create a new sheet set from scratch in just a few clicks. So we open the sheet set setup, where we see an overview of all the sections that are defined in our BIM project. So we, of course, only select the sections for the East building, and we can see a preview of this, how they will appear on a sheet. Of course, in this case, they are indicated in a red color, meaning that they don't fit on the sheet. So we can fix that by either choosing another template with a bigger paper size, or by changing the scale of the sections. So in this case, Peter is changing the scale of some of the sections from 1 to 50 to 1 to 100. If we then go back to the preview, we can see how the sheets will look like, and everything nicely fits on the sheet. So if we are happy with this configuration, we can press the Create button, And automatically, it will start updating all these sections in a background process. So if we zoom in a little bit on the project browser, we can see that all the sections are being updated, and we can see a visual indicator that shows the status of all these 2D drawings. So we don't have to wait until all of this is finished, and we can just continue and show some other new interesting ways for creating design documentation in V20. A first interesting new way is for schedules. So schedules are bill of materials or quantity takeoffs, and we have improved significantly the performance of creating schedules, and we have also added several enhancements. For example, it is now possible to add elevation views to your schedules, which is a very handy feature if you want to create a window schedule, for example. You can see a visual preview of the windows in the schedule as well. So in the meantime, our sections were updated. So we can open a floor plan, and on a floor plan, tags are generated automatically. So in this case, some wall tags were added, but we can still add other tags as well. Tags are completely customizable, and you can add them in an automatic or manual way. There are also new ways in V20, for example, to add tags for compositions. Composition tags will show the different material layers that are used in the specific walls or slabs. So there are a lot of possibilities using the BIM tag technology. A third enhancement for design documentation is for elevation views. If we open an elevation view, we can see that an elevation hatch was generated for the walls. This is because now it's possible to add elevation hatches in your BIM library. You can choose between solid or pattern hatches, and they're also generated automatically on the elevation view. So this gives, again, another dimension to the generated drawings. So with these kind of improvements, we have tried to make it a lot easier to generate and sync all the 2D drawings with your BIM model, and hopefully giving you more time to focus on the actual modeling or the design of the building. So with this, we are going to switch to another topic which Kevin will introduce, and which is about collaboration and issue management, or rather the lack of collaboration.
Thanks, Stephen. So, construction projects. They tend to have a lot of project teams located in different places. And a common theme is that issues will come up. And so it's important for how those issues are transmitted and communicated. Whoa, okay. Collaboration and communication is one of the largest sources of problems. If something goes wrong, there tends to be a lack of communication associated with it. For example, there was a lack of communication that the escalator should actually go all the way to the floor versus just 4 steps above. And there was a lack of communication that the bank teller should actually not be at a seated position or where you have to jump to hit your pin. But seriously, lack of communication can lead to design errors, which leads to rework and financial implications for projects. So back to the original question, how do you transmit and communicate issues that are found? IFC plus BIM collaboration format provide an interesting workflow. So with BIM collaboration format, it allows BIM applications to communicate model-based issues for IFC models that have been shared amongst the team. But let's take a closer look at this workflow. So the West building, the design of the West building is a little bit farther along than the design of the East building. The architectural, structural, and MEP designs are nearing a point of a submission deadline. A project manager has done a review and created a set of BCF issues that are being shared with the team that the team must deal with before the submission can be done. So Jacob can log into the open platform where the project manager created the BCF issue set, and then he can get access to that overall set. One of the things that we noticed is that one of the first BCF issues is related to MEP. So, and you heard earlier that Jacob's a pretty quick guy. He's also talented, so he's going to put on his mechanical engineering hat. But we also saw in the application store, I don't know if you saw the icons that were listed, but AX3000 was one of them. So this MVP layout was created in AX3000, which can be brought into the BIM and incorporated into it, and we can start working from there. But back to the BCF issue. So with the BCF issues, each one of them has a unique ID, has a description, we can associate a viewpoint with it, and it can also have selections associated with it if that's applicable. So in this case, we can select on the viewpoint, and we're taken to that portion of the mechanical layout that needs to have a new duct branch or duct branch created for it. So we can start from this point. So we can add the vertical to that set, and then we can begin to create the duct branch by selecting Connect. And so what this does is that it gives us options for what this duct branch will be created with, or what it will look like. We can select one of these, and then we can go to a next level of refinement so that we can identify which segments we want to have included. We can select or deselect those, and we're getting visual feedback updating what the layout of that duct branch is. So once we get the set that we want, then we can finalize the creation of that duct branch, and the main ducts are going off the size of the fitting size at the vertical, and then the others are going off the fitting size of the terminal. But once this is created, we can also continue to work with it and direct model it. So if we needed to adjust the height of this based on other clearances or other issues identified, we can use BIM drag to raise that and lower that whole branch, and that maintains the connections to the duct branches that are going to the terminal as well. So now we can go back to the BCF panel, and we can mark this issue as resolved. And then when we refresh the panel, we'll notice that there was 5, now there's 4, 1 less. We could also include a description with that, and if we wanted to capture another viewpoint, we could do that as well. But let's continue on. This BCF issue is looking at how we need to change a portion of the duct branch from rectangular profiles to circular profiles. So in similar fashion, we can select that viewpoint, and we're taken to the location of that area. We can add some other selections to it, but what we're going to be doing is similar to what you saw with the compositions panel, but this time with the profiles panel. And maybe these ducts need to be changed because they're in an area where the ceiling is exposed, and it would be better to see circular ducts. But once we have the selections we want, we can then drag and drop. We can select the profile that we want, and then we can drag and drop that onto those selections. And the overall selections update to change that profile. And it keeps everything intact, so we're not having to touch and adjust different elements as well. So again, we can go back to the BCF panel and mark this issue as resolved. And then refreshed, and we're down to, and we have 3 other issues. So Jacob's now going to set that mechanical engineering hat aside and put on a structural engineering hat. And what we can do is we can open the structural frame that is actually an XREF that's associated with that west building. And we can access the BCF issue. Again, with this one, what we're looking at is that it's going to be adding 2 refined structural details to some intersections and all other similar intersections within the model. So we can select on the viewpoint to see which location that is. Now, it was mentioned earlier, but Propagate got a powerful new companion in the form of a detail library. And it's actually accessible on the detail panel. You'll see some other examples as we go, but as was also stated, as you start to realize how you can use this, the library is going to increase. So you also have filters and ways to select and get to what details you want. So in this case, we have 2 frame members meeting the beam, but our structural team has done a more detailed design, which we can click on to open. And here we get a visual of what this detail is, and we can select propagate. And so now what's happening is it's scanning the model to find similar conditions to the one for this detail, other places that we can apply it, and then we'll start to also get feedback on the degree of match to that as well. So fairly quickly, we've got numerous locations on the overall structural frame. The green region is outlining where that detail is being applied, and you can visualize what the application of the detail is going to look like. Similar to what you may have seen before, you can deselect or select these as well, and to ultimately refine your selection set also. And then you can finish the propagate process, and it's directly modeling those details within the BIM at all those locations that were identified. I know you've seen that before, but come on, it's fairly impressive. Kind of building on that theme, with the second version, we see that we have a column going through, and then we have beams, so we're going to need to support those beams somehow. So maybe a plate and bolt connection might be a smart thing to do. We can also access a detail here. You'll notice there's a number of filters that can be associated with these details as well. So you can get fairly precise, which makes it easier to find in the library. Again, we can open propagate, and going through the similar process of scanning the overall model for similar conditions and the degree of match. And what you'll see coming up as well is how we can also create and add details to the detail library, which provides an even exponential degree of power. So here again, we have the region of influence for this detail. We can see what it's going to look like when it's being applied, and we can finish the propagate process. So one thing to note with these details is that they are fully parametric as well, or they are parametric, or they can be parametric. And so if you need to make a change at an instance, all that information is being brought into the BIM as well. So if we wanted to select the plates and the bolts, and if we wanted to adjust the size of the plate, change the bolt configuration, we're able to do that from the properties that are part of that detail that has been added. So not only can you propagate the detail across, you're also able to refine it and shape things as you move forward with it too. So Jacob's moving pretty fast, as we've heard he always does. So let's go back to the BCF panel. We can mark this issue as resolved. And again, now it's shared back with the project manager and the team to provide an indication of that these issues have been looked at. Now, Jacob, I don't know about you, but it seems like we're the only ones doing work here. But let's go to one more issue, and then maybe the rest of the team will pick it up after that. So with this one, we're going to be looking at how we can add an analytical model, or we need to revise a version of the structural analytical model for a structural engineer, that one of our colleagues that's going to do some analysis in another program. So again, common theme, we can select on the viewpoint, and well, we see the description. In this case, with creating the overall analytical model, we have options for restrictions and constraints that we can set on the model. So in this case, we'll select parallel deviation within profile bounds, and we'll hit OK. So what's happening here is that it's now creating the analytical model for that structure. It's identifying the member locations and the member intersections so that the nodes are identified, and we can take a look at we can investigate if it's the way it's supposed to be. So, and what you'll see as we start to zoom in is that the nodes will be transparent circles. And see, so then we can do a visual inspection if the connections are coming up the way that we hope, which in this case means a single node versus multiple nodes. And then surprise, surprise, there's one that's not right. So in this case, if we look at this, it's definitely not what we want. So we could go back to the model, make adjustments with the members, or we can start to look at how we can, if we can relax the restrictions and make adjustments to that and still meet the intent of what we're trying to do. So by selecting the members, we can then get to the restrictions, and we can select non-parallel in this case and see that it goes from 2 nodes to 1. So we can mark this issue as resolved, but we can also put a note into this if we wanted to, telling the structural engineer that when they're doing an analysis to look at this particular area to make sure that it's still meeting the intent of the overall design. So now we've gone through R4, and we'll, Teeman, why don't you guys come up and try one, and we'll see how the architectural team is doing, and Mr. Light UI Peter is doing.
We can see on. You didn't switch. Okay. Now we see the Light UI. So we can see on the list of Peter's screen that there is one more BCF issue remaining. It relates to the architectural model of the West building, and it says that connection between the wall and the roof hasn't been detailed yet. So we will use this to show you how you can create a new parametric propagate detail and how you can add it to the library to apply it to this model. So we can also activate a section plane to see how the detail looks like at this moment. So we can see that the different plies of the compositions haven't been connected yet in a correct way, and this is something that we will try to fix now. So in order to create a new detail for propagate, we will start from a new drawing because it's easier to work on an isolated detail. And we will model a wall and a roof entity with a similar composition as the one in the West building. I say similar. It doesn't need to be identical because we will later on parameterize the detail so that it can be applied to different situations. For example, different angles or different thickness of plies. So the actual conditions don't need to be exact. So Peter will now start modeling this connection ply by ply. So we don't use any templates or approximations or 2D templates to generate the details, but details can be modeled in real 3D. And according to us, this is very important because it gives you, on the one hand, the complete freedom to create a complex detail in 3D, which can be very hard in 2D. And also later on, it will result in more accurate quantity takeoffs if you want to generate a bill of materials. In order to create such a detailed connection, in this case between the wall and the roof, you can use the same direct modeling tools as you know and as we've seen before, like push-pulling or extruding to create the detail ply by ply. So we are now adding an insulation block and an L-shaped profile as well. And we will also add a roof cap on top of the wall. So we are using just exactly the same direct modeling tools as we've seen before to create this detail. Now that the detail has been created, we can add it to the library in just a few easy steps. We have to define a name, we can choose a category, and then we have to select the base solids and the detail solids. So in this case, the base solids are the wall and the roof entities. And the detail solids in this case are the roof cap, the insulation block, and the L-shaped profile. We also have to select a section plane because this is a 2D detail connection. And then we can specify a thumbnail. So we can generate a thumbnail of this detail to make it easier to recognize it in the library later on. And we can also add tags. So in this case, we are going to add the tag rain screen, which we can later on use to filter the detail library and to more easily find this detail in the library. So we can open the detail that is now available in the library. And so far, this detail hasn't been parameterized yet. And last year, we showed you a new technology called Parameterize, which automatically converts a dumb solid into an intelligent parametric object. And we're using this exactly the same technology to also parameterize this detail. So when we parameterize this detail and we animate some of the parameters, we can now see that this detail can be applied to different conditions. So for example, the angle doesn't need to be exactly 90 degrees. We can still add some additional constraints. So in this case, we are adding some constraints between different faces of solids to make the detail behave exactly as we would expect it. So for example, we add an additional constraint between the roof cap and the wall. And if we then animate the detail again, this is exactly how we would expect it to work. We can also change some other parameters or adjust, for example, a tolerance. And once we are ready, we can use it to propagate. So it's very simple. You can just simply drag and drop the detail from the library onto the model, and it will start scanning the entire model for all similar situations where this detail can be applied. So in this case, it has found the 4 different connections between the wall and the roof. And this is quite interesting because there are different angles between the wall and the roofs at different places. So with parametric details, you can also cover all these possible cases. Also, if we have a look at the section, we can now see that the 2D detail is exactly as we would expect it. So we can consider this last issue as resolved. So we can go back to the BCF panel, we can change the status, and if we have a look at the list of BCF issues, we can see that everything is resolved. So it's time to switch to another topic, manufacturing and fabrication.
BricsCAD Ultimate. You've seen a number of aspects of the workflow so far, but there are a few key ones remaining, one being mechanical. We're at a point in time where digital fabrication is becoming more common, where we can go from model to fabrication to product. If you think about it, there are a lot of different mechanical assemblies that can be part of a BIM. Window assembly types, curtain walls, elevators, and a number of others. Mechanical allows us to step further into this realm. It allows us to incorporate fabrication-ready components into the context of the BIM to inform the design. Let's look at an example of how a fabrication-ready component can be incorporated into the flowing station. Detail is great if it's useful. Over the years, I've seen a number of BIM models that have modeled everything that could be modeled, but the detail really didn't serve a purpose. It definitely didn't serve the purpose of digital fabrication. The terminal building has a placeholder for a stair and an escalator that's going down to the platform. But the mechanical team has let us know that they've developed fabrication-ready escalator that they'd like to see how the look and feel is. So we can incorporate this fabrication-ready component into the BIM by replacing this block and adding the escalator assembly. And what this allows is, from an architectural perspective, we can start to look at the spacing, tolerances, clearances, the overall look and feel. From a mechanical perspective, we can start to investigate if adjustments need to be made. If we need to change the properties that are associated with the escalator, we can do that directly. Or we could go and change the system directly if we wanted to as well. From a technical standpoint, we're still in BricsCAD BIM. We're not having to translate information from another tool, so we don't have to be concerned about data loss. And also, since we're in the BricsCAD BIM environment, we can open this assembly directly. We can start to explore detail in numerous ways. One of the ways, an exploded view, systems overview, kind of provides a way of looking at the detail of this. You can look at static views. You can also look at it in an axon view, zoom in, start to explore different areas. And we can also animate this and just sit back and have fun watching it. But what this also, the animation also informs not only the quantity of components, and there are just a few, but also the fit and relationships of things as well. So, and just to harp on the detail, there is a slight bit of detail that's associated with this escalator assembly, and the mechanical team will be doing presentations on the escalator and other sessions throughout the conference, and I'd encourage you to go see it because it's quite fascinating what you can do. But as you can with everything else, if we made adjustments to this assembly within this file, we could save that, we could update it within the BIM, and then we can look at the context of the changes in the larger BIM environment and inform the design further. BIM plus mechanical, enabling detail with a purpose. So Teeman, why don't you take us into another visually stimulating topic?
So the final topic of the BricsCAD BIM Ultimate Workflow is visualization and rendering. So unless you are a professional visualization specialist, you might know that rendering can often be quite hard. You have to export your model to a rendering application without losing data. There are a lot of difficult settings that have to be set correctly. You often have to wait a long time before you see the actual rendering result, and which is hopefully correct. So it can be quite hard. So we think there should be a better way. And this is why we have partnered with Enscape 3D. Enscape 3D has developed a real-time, high-quality rendering engine that will now also be made available on top of BricsCAD BIM V20 as part of the Bricsys collective. So with this integration between BricsCAD and Enscape, we will offer an integrated workflow where you can do rendering with very little effort needed. So let's have a look at how it works. So from within the BricsCAD application, we can launch Enscape. We can launch Enscape. It's a one-click startup. So this means that there is no export needed or no dialogue. So it's very easy. In just a couple of seconds, you see the result of the rendering of your model in the Enscape window. The advantage of this workflow is that as much as possible, existing data from the BIM model is leveraged in the Enscape window. For example, saved views. So views that are stored in the BricsCAD model are used in the Enscape application to navigate to interesting viewpoints. Also materials, so you don't have to define materials later on. All the material properties are used from the BIM model. And also some high quality rendering materials like for the water or the grass are available to add some additional realism to the renders. It's also a tool that can be used to create animations, so not only static renders but also animations, so we can easily add a first keyframe at this position. We can move along the west building, so we can have a look at how it looks like. We can move to a second position where we can add a second keyframe, for example, like here. And then we can move further below the west building to have a look at the terminal and the canopy and how the lighting influences the design of the canopy. And we can add a third keyframe at this position. So we can then choose the total duration of our animation that we want to create. And then we can see a preview of this animation. If we are happy with this animation, we can of course export it as a video to show the animated video as well. Also, the geographic location is used from the BIM model. So this means that it's also a useful tool for daylight studies. So by changing the time of day, you can see how the lighting will influence your design, so you can change to different points in time. And a last final benefit of this integrated workflow is that we also support real-time changes. So, for example, if you add some changes in the BricsCAD BIM model, you add some geometry, or like we just did, we activated a clipping section, you will see these changes reflected in the Enscape window as well. So if we go to a viewpoint of the west building, we can see a sectioned view of the west building. And if we zoom in a little bit closer, we can see how the three models that we just created today, the MEP model, the structural model, and the architectural model, nicely come together in this integrated BIM. So with Enscape being part of the Bricsys collective, we have enabled new ways for visual storytelling available in the BricsCAD BIM workflow as well.
Team, you get all the claps. So, oh, thank you. Thanks for that token one, Eric. I appreciate it. So, in summary, BricsCAD Ultimate, it's a powerful workflow. I mean, what we've showed you is that you can intuitively model, letting design lead the way. The integration with Grasshopper enables design ideas to be created, visualized, refined, and incorporated into the BIM. Data and level of detail can be added as the design goes. IFC and BIM collaboration format panels allow multidisciplinary teams to collaborate on issues more effectively. Ways the power of Propagate can be used continue to expand to multiple disciplines and other levels of detail. BIM plus Mechanical is enabling digital fabrication workflows. And last but not least, the Enscape integration enables visual design storytelling. BricsCAD BIM version 20, unlock your design excellence. Thank you. And thanks to Jacob and Peter, because they were doing all this live.